So everybody, what are we going to talk about today? We're going to talk about decoding the science of user experience in M365 and Power Platform. What does that mean? Well, I'm going to hand it over to my good friend Hugo to kick it off.
I like to use examples for everything. So today we're going to show you, or we're going to ask you this question. If you could make people do what you want within your application, what would you make them do? And this is very cool because we are going to show you how we can hack people's brains and convince people to do exactly what you want them to do within your application without really them knowing. And we're going to talk about various other concepts like cognitive load and things like that, because the key to make people fall in love with your application and use your application is to make people feel that they are geniuses, right? Feel that they understand what's going on and totally not make them feel like they're stupid when you use their application. And we'll show you some examples of that. The one thing I want to make clear, though, is that we're not going to show you here, what size to make a button and how much space to put between buttons and things like that. We're going to teach you the scientific rules behind all this logic so that you can go back then when you build your applications or your websites and you can leverage these scientific tools in any way, shape, or form you'd like. All right, David, I think you got some fun activity for our friends.
I do. Yes. And fun fact, everybody, that's how Hugo and I got into co-hosting and co-presenting together is he told me, you're not stupid. And would you like to And I'm like, yeah, of course. So the proof is in the pudding already. So, all right. Now, everybody, normally I will say.
I was trying to make David do what I wanted, really.
Yeah, the lawyer said we're not allowed to talk about that anymore, though. But anyway, so normally I'll preface this next scene with we're usually doing this in person with everyone. We're at big conferences or events, so we get a lot of interactivity and shouting out. Still want you to be interactive, still want you to shout out, just going to have your neighbors and your office workers looking at you like you're crazy. And we're okay with that because you're going to have some fun. Okay, so we're going to start out with an activity. What I'm going to show you is a number of slides, and you have to say the color of the text, not the word out loud, and as fast as possible. All right, everybody ready? Let's see a thumbs up. Chuck is ready to go. Love it. All right, ready?
Green.
Blue.
Yellow.
Red.
Green.
Yellow.
Purple.
Orange.
Brown.
Pink.
Black.
White.
Blue.
Oh, what is that? He cheated.
Stripe.
All right.
Plaid.
Plaid, right? They've gone plaid. Ludicrous speed, right? Okay, so what is that? Well, that is the Stroop effect, and it occurs when there's a natural reaction between your brain and what you're seeing. So you want to keep in mind that you can harness things like this, right? Things like the ability to understand how the human brain reacts. When you show something that someone has to read, but then they have to not read it, they need to analyze what's actually happening on the screen, that takes time. That's called cognitive load. And there's a conflict in your brain that happens when you're trying to force someone to make the difference or choose the difference or understand the difference between what they're reading and what they're actually trying to accomplish or seeing, right? Okay, so that's just the beginning. We are going to talk about a lot of different things, effects and laws and principles throughout the session here today. It's going to be a lot of fun. But first you may be thinking, who are these crazy guys and why should I even care about them? Well, with me, first and foremost, is my good friend, Hugo Bernier. Hugo, you want to introduce yourself? Hugo, the architect Bernier, by the way.
Hi, Hugo.
Hi. I like to call myself the world's easiest developer because I always try to find clever ways to do some things with the lowest effort possible. Former Microsoft, former McKinsey management consultant, and now I work at Decoding, working in mostly AI. And with me is my friend David.
I actually knew that was always the case because Hugo has to be more machine than man with all he gets done. So I knew AI was natural progression for him. Okay, my name is David, not Hugo Warner, right? When we worked together at Microsoft, everyone always thought we were, you're welcome, okay. Chuck, thank you. When we were together at Microsoft, we always were mistaken for one another. Well, I now work for Quizzitive. I'm a big fan of the community, big fan of user experience and graphic design, taking things like animations and putting them in places where they provide value, not just gratuitously adding in information, right? So we want to make sure that we're using things in the right way. You're going to see a whole lot of opportunity today. And so what does that bring us to? The objective. As Hugo said, we're going to decode the psychology behind UX in Microsoft 365 and Power Platform, right? So we're going to talk in a very rapid fashion today. Normally, this is a full day workshop, so you're all getting a condensed version of this. We're going to identify psychological barriers in modern UI. We're going to talk about laws of perception, so you're going to hear things like you've already heard, one, which is the Stroop effect. You're going to hear things about Miller's Law and Hicks' Law. We're going to talk about applied science-based UX to business applications, and actionable insights to all UX operatives, right? So you're going to be able to walk away from this today being able to do something. Now, you may feel overwhelmed as you walk away from here today because there's a lot of things we're going to cover, but we don't want you to. We want you to pick one thing. Just pick one thing that you found value in today and go apply that at your environment, whether that means within SharePoint, whether that means within Copilot, whether that means within Power Platform. You can provide these effects in all those aspects. So make sure that you only pick one, don't overwhelm yourself, but then try another after that fact. Okay, so now I'm going to kick it back to Hugo, who is going to walk us through a fun little exercise where we're going to understand the human brain and the power of our vision.
Thank you. And I always like to say, if you're only going to remember one thing from this session, is my Venmo account. All right. So let's talk about the importance of visual things, right? Because we have to understand where vision fits into auditory, touch, and things like that. What you see here is a predator, right? And it's built into us as humans for our survival to be able to recognize danger and to recognize things that are about to eat you, right? If you see this face in the jungle or whatever in the darkness, you know you're in trouble. But if you understand that our brain is actually hardwired to recognize shapes, colors, and in fact, it's so good at recognizing things that we will pick up faces anywhere, even if it's not really a real face. And this is actually, if we look at the next slide here, we have another example of this. And so this is pareidolia. And it's a phenomenon, again, that hacks your brain into recognizing things that could be potentially dangerous. I like the animation here. Cool. Now, let's look actually one step further. We don't only just recognize shapes and colors, but we actually recognize motion, right? So this animal that's walking towards you is not a cuddly little animal, but the one thing you may even have noticed, even though this is a kind of a grainy video with kind of relatively low resolution, you probably noticed the flies that are flying around the animal, right? So we're picking up tiny little elements of motion because if something is moving, it's probably more likely to be attacking you than something that's not moving. And this is what we call the visual dominance effect. We're really good at recognizing vision and shapes and things like that. And now we don't really need it to survive, right? We're not about to get attacked by a lion in our houses, but it's still ingrained into us. And if you don't believe me that a vision is more important than, let's say, hearing, let's do a little example. David.
Yes, absolutely. Thank you, Hugo. So we're going to have a little exercise here, everybody, and our audio should be coming through just fine. We've set this up and tested it. So we're going to show you a series of videos. That's going to be the mouth of someone, and we're going to ask you, what do you hear based on what you see? You're going to see how that visual dominance effect is going to overtake potentially what you're hearing, and it's going to shape what you believe you're hearing. Okay, so let's go through it. We're going to have our first video here.
Ba, 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 ba.
Okay, so what did you all hear? Likely you heard ba, 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 right? Feel free to throw stuff in the chat as well. You heard ba, ba, ba. And part of that was because of why? Well, maybe it was because of the way the lips are forming, right? You've got the B as in boy or boat, right? You see the lips going together in the sense that you're hearing ba, 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 like Jonathan said in the chat. Absolutely, right? But what if we were to change that up? Okay, let's try again.
Ba, 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 ba.
All right,
ba,
yep, very
ba.
good. Jesse, excellent. Jonathan, so you're hearing fa, fa, fa. Now, the visual side of that is that you're seeing the lips change, right? So now the lower lip is going on the inside of the tooth, which is going to be indicative that you're hearing an F within it, not a B. So you're going to hear fa, 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 right? Okay, let's take another look.
Ba, ba, ba.
Actually, sorry. Let me go that again. Just reset it. So there we go.
Ba, 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 ba.
Now that time was a little unique because what you saw was the lip going underneath the teeth, which was indicative of the person saying fa, 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 as in Frank, right? Or foil, or something like that. But what you actually were hearing was the B version, as in boy or boat. Ba, ba, ba. So the visual dominance effect was taking over because what you were seeing the mouth do was what you believed was going to result in something like an F-based sound. But what was actually being audibly present was the B, ba, ba, ba. So it shows, to Hugo's point, that you're going to hear what your mind sees over what you're actually hearing. And Hugo, tell me more.
Well, this is something called the McGurk effect, and this is how scientists are able to understand that vision takes priority over hearing. And you'll see other examples today where we were able to categorize and sort basically what effect takes priority over another very soon. But first, I think you had some fun little another example of the McGurk effect in action, right?
Yes, we have exercises galore today, everybody, so it is your lucky day. We are going to take another look at how that multisensory perception can influence what it is that you think you're hearing. So this is a fun one. Let's do this one. All right, so I think we all heard what we believe we are reading on the screen, right? That is embarrassing. Very simple, no problem. Well, is it possible that what we see on the screen will influence what we think we hear again, much like the mouth did? Because before we were analyzing the video that was going on. Here, we just have text. We're not actually seeing any moving spaces or moving people or anything that's causing it. We're just reading text. So let's see how that can influence us. All right. Now, at first, you probably still heard that is embarrassing, right? But as he continued to play and you read what was on the screen, started to sound like that isn't my receipt. But you started to wonder, is that actually going on? Well, let's take another look. Yep, starting to sound like what it is that we're seeing on the screen. How about another one? Pretty amazing, right? Doesn't end there. Pretty amazing. One more. All right. So we've just proven using two different methods of analysis for your vision. A moving image along with just still text takes dominance over what it is that you're hearing. Now, in all those cases, they were all saying the exact same thing. But what your mind heard was influenced by what your eyes saw. And so that's a power that you can possess to contain and control using your application. All right, Hugo.
Let's take it up a notch. Yeah.
Yep.
All right. So now that we've established visual dominance, let's talk about what happens within the visual domain that your brain interprets and how we can take advantage of that. And that's something that we're going to, that's something we call Gestalt principle. Well, we don't call it that. It's called that. And it's based on this, the following. Let's actually go to the next slide. What you'll see on the next slide is, well, I don't know what you see, right? you probably see 2 triangles with 3 circles. But the reality is there are no triangles in this shape, and there are no circles, right? We actually see the blank area as if it wasn't real shape. And that's something that our brain is really good at. Our brain is really good at completing things, looking for missing things, and interpreting that. In fact, you always see your nose when you're looking at things, but your brain learns to remove the nose from your visual input. Otherwise, you'd just always be staring at this thing that's in front of you, right? So your brain plays tricks. Like it shows you here a shape that's not there, or it shows you shapes that are not there. Now let's see how we can take advantage of that. Let's take a series of shapes. So you probably see here 4 rows of circles and triangles, right? But look at what happens when we change one aspect, right? We just changed the color here. But now immediately your brain turned these 4 rows into these 4 columns, sorry, into 3 rows. And that's kind of the principle here. Now, in fact, let's just move things around. And you probably now see probably 2 or 3 groups, depending on how your brain is working it. But you see all the items that are the same color together. And yeah, you see Pac-Man. And that's the principle of similarity. Next slide, please. That's the principle of similarity. And we can take advantage of the principle of similarity when we do our design. And so if I show you a very high level example of an application, I don't even need to show you the actual application, but you can see that there's already some elements that are similar, either similar in color or shapes or different aspects here. And because I'm showing them with a principle of similarity, you understand from that these items are going to behave or work the same way. So for example, buttons being in a consistent color, or items being presented in a consistent way. Now let's use another principle. So we're gonna, now all the shapes are exactly the same, right? They're all circles. But look at what happens when I do this. All of a sudden, you actually notice probably that these 3 items are part of a group. And if I move that group around, you'll see that you're now perceiving a different group. And that happens, it doesn't have to be that particular shape or that particular color. If I just even do a slight border around items, you perceive these items as part of a group. Now let's see how strong that is. Is that more important than the principle of similarity? Let's see. If I move the container here, next slide. There you go. All of a sudden, even though I had similar shapes and similar colors, by putting that border around those 3 objects, I've grouped them together. So that's telling us that the principle of common region, which is the next principle we're talking about, takes priority over the principle of similarity. And I'll use a really crappy example of common regions, but this is something that you've probably seen before, right? And I hate that I'm using an old Windows dialog to show a good example of user experience here, but you'll notice that there's common regions here. These either with a tab, with a group, you're able to see that these objects are combined together and relate to each other. And that makes it a lot easier to perceive those things, because if you just focus on the group here, select printer, page range, and number of copies, it's just made things a lot easier for you to perceive. Now, let's kick things up a notch. All right, so take a look at these shapes. And when you see them, you perceive probably them as 2 separate groups, right? And if I highlight them for you to make it really obvious, there you go. Now, what happens when I use the principle of similarity and change the color? You still see the items as 2 groups, but within those 2 groups, you probably see a group of highlighted shapes. So that is telling us that the next principle, the principle of proximity, takes priority over similarity. And how does that apply to a user experience? Again, if I show you an application here, now I've made everything the same color on that app. But even though they're the same color and they're exactly pretty much the same shape, you can see just by the distance between those items that some items are grouped together and some items are separate from others. And that is really the principle of proximity. All right, let's go faster here. Let's show you another group of items. Now you see these dots, they don't seem to be related other than having numbers next to them. But look at what happens when I draw lines. Oh, now you see 1, 2, 3, 4 groups. And if I, in fact, let's show you those groups. Let's go. Boom. Next. All right, so you see here, I have items that are grouped together because of the principle of proximity, right? The number 2 and 3 are closer together than 1 and 2. 4 and 5 are closer together than 3 and 4, and so on and so forth. But let's look at what happens when I draw lines between them. Immediately, regardless of the distance between those items, I was able to group them together, right? And visually in your brain, you now see 1 and 2 together, 3 and 4 together, and so on and so forth. Let's change things a little bit. Let's change the sizes of the items. All right, so now, again, you probably see that 2 and 3 are probably together, and 6 and 7 are together, and 4 and 5 are probably together just because of the sizes. That's what we perceive here. But let's draw some lines between them. Look at that. Regardless of the principle of similarity, I'm able to create groups that I'm able to override what you see in your brain. And that concept is the concept of connectedness. Ooh, fancy little image here. And the principle of connectedness is something that we can take advantage of in our user experience. For example, right, in an app where you have a checkout, to be able to show a concept of a process here. One screenshot that I don't have in here right now, but I usually do, is when you look at the directions or the Maps app and you ask for directions on either Google or Apple, you'll notice that there's actually a line that connects the to and from, or from and to, or destination origin, whatever it's called. And that's, again, to help illustrate that these two items are linked together. But that allows them to put additional information between those two items that are not going to confuse you. All right, so let's continue with our fancy lines. And let's show you a new set of lines. Now, you may notice that your eye perceives 2 lines here, right? And again, I'm sure if you think about it, you may see something else. But the first thing you saw when you looked at this was 1 straight line and 1 curved line. And in fact, if I change the color of the dots, you can still perceive the straight line and the curve, even though the colors are different. And that's the principle of continuation. I always have a hard time saying that word. But continuation is something you see all the time. In fact, let me show you an app that you probably use if you're cooler than I am. Here's an app that uses the principle of continuation. Let me show you where that is. Oops, look at that. What I've been able to do here, and that's what they do with their app, is they're able to show you that there are more things outside of the screen, and it will encourage you to scroll to see more items. It's a very simple thing to do, but instead of having to say more or load more or scroll to the right, by just showing you a partial item, you were able to understand that there are more things available to you. And this principle of continuation is something that we'll take advantage of when we design forms. In fact, here you see in a sample application, we have the same concept of continuation. Again, you're not even seeing what the app is about. All you see is shapes. But I bet you that you already picked up that at the bottom on the left side, that you're able to actually scroll left and right. And on the top right, there's the big red rectangles that you're able to scroll them. And so that's instinctive for us to be able to continue things. And that's what the principle of continuation. Now, we can take advantage of that when we design forms. So here's an example of a form. Let's look at what happens to your eye when you're trying to read, right? So you go from label to field, and then you go through your buttons, and you go through the other set of buttons, and you continue like that. Now let's change that a little bit. Let's do another version where the label is just above it. And look at what happens to your eye when you try to go through that form. Now your eye more naturally goes through that process. So I'm not saying that having labels on the left and fields on the right is evil. I'm just suggesting that if you want your users to be able to scan through a form a lot more easily, you might want to consider a layout where the label is on top. Now, there's another concept that we kind of talked about or made allusion to, which is, well, actually, let me show you a shape. And you probably see a circle, right? Because your brains fill the blanks so quickly that I don't have to tell you it's a circle. You just immediately see it. This is something that is often used by big brands. For example, you may have never noticed that this is not the letters I, B, and M. It's actually a bunch of lines that happen to make the shapes IBM. And this is probably a more commonly seen shape in this world of sports. I believe this is hockey. This is the principle of close. Speaking of close, this is the principle of closure. And closure is basically that your brain is able to continue and close things that that are left open. And this is, again, if I go back to an example of an app here, you'll see that this is used all the time. So for example, this is the Disney Plus app. You'll notice that on the left and the right of the Mandalorian poster, there's two little posters, and you can actually tell that it's not just a bug here. There's actually something there, and that your brain is going to be able, thank you, it's going to be able to continue those images. And that happens all the way. Yeah.
Do these have Gina Carano in them?
Now they do, since the settlement. Yes, they do. All right. So, okay, so we've shown you here how some of the principles kind of work together to help overrule some of the things that you would normally do. I think this is a concept that we call content hierarchy, and how you lay out your content. Yes. Yep.
Well, I was just going to add. One thing I was going to add to what Hugo's been showing off is that you'll notice a lot of the samples that we're showing are commercial samples, right? And we may be thinking, well, wait a second. Most of what we're doing is internal applications, SharePoint and Power Apps and Power Pages and et cetera, et cetera. There's no reason why you can't bring the strong UX that you find in the commercial applications like Instagram, like Netflix, like Disney Plus, like some other samples that you'll see us using within the scope of an internal application. These organizations, Netflix and Disney, and in the case of Instagram would be Meta, they spend billions of dollars on research and understanding the best way to design. It doesn't mean that those tools are not available to us to build and match what they are building. So take advantage of the design principles that you find within the scope of those applications and apply them to the applications that you're building for internal purposes. Hugo,
all right, so let's see. Yeah, let's see if you believe me, right? So I just told you that using colors and shapes and sizes and distances, I can control exactly what you see and what you perceive. We're going to show you a slide here, and I think this is David's favorite slide.
Oh, it is. It is my favorite slide. Now, it's also the one that requires you all to say you're not going to sue us for controlling your mind. So we need to make sure that we've got those all signed affidavits. Excellent. Okay, is everybody ready? Because we are going to prove right here and now that with user experience, you can control the mind and where people look. Were we right?
Let
Throw
us
into
know
the
with
chat.
a reaction. Yeah.
Very close.
Oh, very
Jonathan,
close.
you have to open your eyes, though. You have to open your eyes, though. Mike, yep, excellent. Very good. Thank you. This is just one of my favorite slides ever, because anybody who challenges the ability that any of this is just, poppycock, I don't get to say that very often, but that this is poppycock or some sort of sorcery or fake news or whatever, this proves that you can control what it is that they are doing. And that is the difference between someone using an app they're forced to and loving an app that they want to use. It's just a very
I'm just craving caramel popcorn. Thank you.
That's you're welcome.
That's right.
You're welcome.
Now let's continue this with a principle called Gutenberg's law. And Gutenberg's law it's something that was called Gutenberg's law because Gutenberg is the inventor of the printing press, the modern printing press. And there's something called the reading gravity that tells you in places where we read top to bottom, left to right, how your eye is going to perceive information on the page. So let's look at what usually happens when you look at a page that's got text, right? If the text is going left to right, top to bottom, your eye is going to go in this direction. It's going to go from the upper left to the lower right. In fact, let's just simplify that arrow. And there you go. And that's something called the reading gravity. Now, if we divided the page in a quadrant, or 4 quadrants, I guess, we would see something that says that basically there's the primary optical area, which is where your eye is going to land. Then there's going to be, let's move next, the terminal area, which is where your eye is going to end up. Pay attention to those because these will help you to control where you want to put the various elements on your page. The next thing is the strong fallow area. The strong fallow area, this is not a spelling mistake, right? We're saying fallow as in the output of a crop, right? So if you plant things in this corner, you're going to have a strong reward. And then the opposite of the strong fallow is the weak fallow. So if you plant things or put things in an application in that corner, they're not going to be used as often. So let's look at how your eye looks at it really quickly. We're going to do a super quick animation. So you come in, you look at an app, you go like this, you go from left to right, then you scan a Z shape, you go left to right again. And if we amplify that to kind of a bigger page with more lines, this is what it looks like, right? So we do a zigzag motion. But we have learned when we read online, it's harder to read online. So we've learned to actually skip to get to the results that we want. And so what we normally do when we look at content online is we'll do more like an F-shaped pattern. And if you don't believe me, this is an example of asking people to look at a series of web pages where they projected infrared light on their eyes and they used infrared cameras to see where they were looking on the page. And you'll see that the items that are darker red are the items that are often looked at. The items that are yellow are not as often looked at. And the blue or not highlighted are rarely looked at. And you'll notice we see this weird F shape on all the pages. That's something that we can take advantage of. If we understand where to lay out things, we can actually put them where our users are going to perceive them. So let's go back to our quadrant. And now let's think more about a app layout, right? So let's move our quadrant a little bit. And now you have still the 4 quadrants, but you have a place where you put your key elements. Then you have a place where you put things that are maybe less important on your page. And then you would actually have probably the least important items on your page would be below, right? So this is where you put your legal disclaimers and your boring stuff like that. Now, if you have things that you want people to do, your calls to action, let's think of let's say a dialog box, would be on the lower right corner, because that's where your eye is magically going to go to at the end, looking for more. But I have another area that I like to call the area of dissatisfaction. Don't go look that up on the internet. It's not a real thing. But I call it that because that's usually where your eye is going to look at if you haven't found the information you were looking for. So this is typically where you would put things like find, filter, help, and things like that. That's where your eye is going to naturally go if you scan the entire page and you didn't find what you were looking for. Now, if you extend that to a full app, like you see here, you will see that we have a typical layout of an app. And in fact, let's add some navigation. Navigation here would go on the left. Now, why do we put navigation there? It's because it is something that we have a tendency to not look at unless we know we need it. It's actually the margin on your pages. And I always, when I do this in a live session, I always ask the audience if they know why there are margins in books. Does anybody know why there's margins
I know.
in books?
Oh, I know.
Yeah,
Oh,
you're not allowed. All right, there are margins in books because books are delicious. And rats and mice love to eat books. When we used to copy books manually, and it used to take a lot of time to manually copy books, books were very precious. But unfortunately, they were not stored in the best places. So rats and mice would start gnawing at the books, and they would eat the precious content of the books. So we learned to add margins in our pages to protect the content from vermin. And that's why we have margins. Now, in a modern day, you don't have to worry about margins in your applications, but it's still something we can take advantage by putting navigation where the margin would be normally. If I lay out a mobile application, you'll see that the same elements are located very similarly, where you have navigation on the left, area of dissatisfaction on the upper right corner, and then your elements in order of priority are placed, usually your content elements here, and your calls to action would usually be at the bottom. And if you wanted, you could even have the navigation on top, right? That is possible. And these are patterns that we see all the time. Now let's look at how does that apply to building an application, right? So I have dialog box here, and I'm going to ask you, well, where do I put the OK and the cancel? Let's look at one option. I have OK first and cancel second. Now, what happens when I read? Let's pretend that I ignore the whole content of the page, but I'll look at the OK button first. Then I'll say, okay, well, I'm not sure if that's what I want. Let me look at the next button, cancel. No, I wanted the OK, so I'm going to go back one and click on the OK button. Now let's switch things around. Whoop. Okay, now when I read the page, and let's pretend again I read the content and everything, I'm going to look at the cancel button. I'm going to say, nope, that's not what I want. I'm going to do the OK button. Yes, that's what I want. Now, you may say, well, wait a minute. Sometimes I want to hit cancel. That's true. But again, we always look at what is the most common activity that we want people to do. We probably want them to do an OK, not a cancel. And look at the arrow that we've got here. The OK indicates a forward motion when the cancel really seems to indicate a backward motion. Now, let's go next. There you go. So again, if I look at the bigger picture here, right, I read the content, I scan through OK and cancel. Now, why don't we just, if the principles of having these items in the right order like this, why wouldn't I move the cancel button and the OK button further apart from each other? Well, that's something you see sometimes, but if you think about the big difference between the OK and cancel, they really are perceived as two very completely separate actions. What I would use if you wanted to lay out something like this, I would use that maybe in a wizard, right? Where you have a previous and next button, where logically the previous button and the next button indicate a forward movement or backward movement. Now, this is an example of Microsoft. And I'm going to show you two examples here. In fact, I had a third example from Azure, but I didn't put in it. So these two dialog boxes are literally one button next to each other on Microsoft Teams. This is the feedback dialog where the submit and the cancel are, submit is on the left, cancel is on the right. And then let's look at the next dialog where the cancel button is on the left and the submit button is on the right. So even Microsoft doesn't always get it right. So you are forgiven for not always knowing what's the right order. Now, let's do a little fun exercise again to understand that we don't really read that well. Tell me when you're done by reacting in the chat. Nobody's reacting. Nope.
See some typing.
Oh, I also just noticed that I wasn't scrolling through the chat. All right. So I'm getting some feedback. All true. That's awesome. Well, let's move forward here. Because it's important to understand that when we read up to 30% slower online. In fact, it's so important that when we read, on average, we read the first two words or 11 characters of every paragraph or every heading. I work for Takeda Pharmaceutical, so let's pretend that Takeda has all these items here listed in a list of options. Takeda Inc. Standard Operating Procedures, Travel Booking, Takeda Inc. Blah blah blah. Right? Well, given how brain works, this is what we see: Takeda Inc. Takeda Inc. Takeda Inc. Which means nothing. So if I really want to make sense of the rest of the content, I have to fully strain my brain, right? Now, same thing here, standard operating procedure. Let's say we decided, well, I know I work for Takeda. I don't need the name of the company everywhere. Standard operating procedures, travel booking, standard operating procedures, expenses, and so on and so forth. It's still, again, noise that I don't need. You could actually change things around and say, well, no, I'm going to do travel booking, expenses, sick leave, parental leave. And then if you really, really have to put standard operating procedures next to it, you can do that, but put it after so that even if people don't read the full content, they can still make sense of what they're seeing. And if it was up to me, this is what I would do, right? It's plain, it's simple, and it's straight to the point. All right, so I bored you with how we read. I bored you with some shapes and things like that. But let's talk about how our brain processes lists. David.
Yes, thank you, Hugo. And that was not boring at all. I loved every minute of it. Even with this being the 700th time I've heard it, I still enjoy it. So I'm sure everyone else did too. Okay, now again, we normally do this in person, so we're going to ask you to remember as many icons as you can. Now, you can't take screenshots, don't cheat. What we're going to do is we're going to show you some icons, and then after 10 seconds, we're going to make them disappear from the screen. Try to remember, without writing them down, how many you see. Once they disappear, then you can write down what you remember. Okay, so look at them, try to commit them to memory. Once they disappear, you may write down or use Notepad or something like that on your computer, and we'll see how many you got right as we go through them. All right, you can write them down. Give you a few seconds here to do that. Just a few seconds. All right, now I'm going to reveal them. How many got all 5, right? Throw in the chat. All right,
That
pretty
was pretty
good.
good.
Yeah, not bad, not bad. Good, good, good. Okay, let's step it up a notch. Same concept. Round 2. You can look at them, but don't write them down until they disappear. Now we've got 9. All right. We'll give you a few seconds. Don't forget
Write
the
them
pumpkin.
down.
Yeah. Yeah. Give you a few seconds. See how many everybody remembered. Everybody's putting them in as they, all right. Okay, good. Okay, so
That's
now
pretty good.
we got 9. How many got all 9? I think Jonathan said 6. Gavin got a few. Was that 6? All right, yeah. Well, interesting numbers. All right, 5 for Jesse. Okay, all right. One more round, round 3. Let's go. Don't write anything down yet. Don't cheat. All right, have at it. Give you a few seconds.
I almost like doing this online better.
We can see the effect. All right, we'll give everybody a few seconds and see what you got. All right, still see some typing. Still see some typing. All right, all right. Not going to show them until we see the enters because they're just waiting for me to show it again. They're like, well, wait, we'll get another one in there. All right, 1, 2, 3,
pretty good.
4. All right, 4, 5. All right, yeah, so that's almost like we paid everybody. All right, yeah. So there were 15, somewhere between 5 and 7 and 9 seems to be the magical number here. Well, guess what? That is called Miller's Law. So what is this? Is that the magical number is 7 plus or minus 2. So most people remember 7 plus or minus 2. So you're looking at somewhere between 5 and 9 things that you're able to commit to memory. And that's important to keep in mind because you're able to take advantage of that within your ability to design functional pages or applications or whatever the case may be. So you look at this number and you might be able to commit all of that to memory, right? You're looking at 7 numbers here, so it might be a little easier to do that. Same with text, right? So you've got things like text here that you're able to commit to memory. Again, somewhere between 5 and 9. You might not get all of them, but you might get somewhere between 5 and 9. In this case, there's only 7, so you're okay to not get 9 out of this. You can make stuff up if you want. But theoretically, what we do is we start seeing things in chunks. Right, so we start to notice things in chunks. So let me ask you this: when you look at this number, what do you see? Do you see a pattern? Do you see a pattern? Maybe.
I think the zero might throw off some people here, but
possibly. Yep. Okay.
And
Jonathan, I think he said he's seeing something there, so that's good. Excellent. Yes, right. So when we get that into chunking, you're able to see. Now, of course, as Hugo said, that might be an odd area code for those in the States, but that might not be so odd for someone over in Europe or something like that. How about this number? Do we see any similarities or patterns going on there? Anybody? All right. Yeah. Okay. Jonathan. Yeah. Good. Whoop. Yeah. Very good. Excellent. So we're looking at some credit card numbers. This, in fact, is Jonathan's credit card number. So everybody feel free to go out and purchase whatever you'd like. He already gave full authority. So
Yeah.
we yeah. So we see that in applications. So I had mentioned Netflix earlier. Look at this. Right? So these are real world applications where the designers and the businesses have spent millions of dollars to ensure that it's laid out in a way that is taking advantage of how your brain is going to be able to consume it in the most successful way. And what do we see here? Well, we see a certain number of elements there, right? Now you do see 6 there, but you also see that little sliver which talks about that continuation that Hugo said earlier over there on the side. Right? Pretty cool how now we're starting to see things kind of combine and work together. Same thing down here. So you see in the trending now section, you're seeing 6 items. And in fact, when we go up to navigation, we see that there as well, right? We're looking at 5 elements. So it's pretty crazy. Now I know we're running a little short on time here. So let's see, Hugo, I think we might be able to move fast if we get it moving. So if we go into Hicks Law, do you want to cover a little bit of Hicks Law and then I'll walk them through the exercise?
All right. So Miller's Law, again, the idea that if you're going to offer choices, right, remember that most people can deal with 7 plus or minus 2. Don't put 72 choices and hope everyone will see it. They won't. Now, the more choices there are, the longer it takes for people to make a choice, and that's Hicks Law. So let's give you an example really quickly here. We're not going to ask you to tell us. We're just going to show you a little decision tree here. So let's go.
Excellent.
Round 1,
Yep.
right?
Round 1.
Decision tree. The Earth is a star, a planet, or a cloud, right? You have to pick the choices there. It's pretty straightforward. Now let's add some more choices and see what happens and how long it takes you to make sense of that choice. Water is dry, fire, liquid, smoke, rock. Right, so now we have more choices and you have to pick the right choice. And even though you know the answer, it probably took longer for you to make sense of all those choices. Let's add some more. Humans are robots, aliens, trees, mammals, fish, insects. Right? Again, it's probably taken a little bit longer for you to make sense of which one's the right choice. And this is something, again, we call it Hicks Law. And it's basically that the longer the decision time that you need to make a decision is a function of the number of options. I like to call this the Cheesecake Factory menu. Because this is just one page of cheesecakes of an entire menu from a restaurant. It's impossible to make a choice in less than 3 hours, right? And this is really the principle. So understand, the more choices you give people, the longer it will take for them to make that decision, that choice. So consider chunking, right, into items that are 7 plus or minus 2 choices each, right? And if you have to group things into groups, into subgroups. Now, What are we trying to do with this? David, I think you got some attention stuff.
Yes, we do. And I did want to go back here and also mention that you'll see similarities in what Hugo had mentioned as well, right? When we were looking at those buttons and you had cancel and OK, you kind of see the right answer here is before the rest of them. But what are you doing? You're forcing the mind to say, well, I believe that's the right answer, but I see more answers to the right. So now I need to process them and make the trip back to the middle to actually confirm that my choice was right to begin with. So this goes into how we lay out our designs as well, right? You'll start seeing a lot of overlapping principles and all of that together. Now we got about 4 minutes left. Oh, go ahead.
Oh, 4 minutes. I was going to say there's something called the serial positioning effect, which is where people will remember things that are either at the start of a list or the end of a list. So if you ever want to hide something, put it in the middle of a list, and it will be a lot harder for people to remember it.
Yeah, Jonathan mentioned in the chat, Cold Stone Creamery looks like that as well, like the, but of course it's summer, it's gonna be 100 degrees here now, so apparently he's getting money off of us going to Cold Stone, because now I think we're all headed there after this. Okay, so one last thing before we let you go, you can focus the user's attention on critical things, right? So we're gonna show you an example of that. We want you to count the number of times the players wearing white pass the ball. Count the number of times the players wearing white pass the ball. Very important you count the white because my grandfather who died as a baby relies on it. Okay, anybody got any guesses? 17, 15, okay, not bad. Very close, excellent. The correct answer is 16 passes. But did you notice anything else? Did you notice anything else? Oh, Jonathan, okay, but I was distracted by the gorilla. Jesse, the gorilla, yep, okay. Did you notice anything else? Anything else? Whether it was told to you on this call, whether it was in the video, did you notice anything else or hear anything else? Nothing. Anybody? Okay, I'm not going to say this, John. All right, let's rewind. Let's see if you notice. So yes, there's the gorilla.
Aren't there supposed to be 3 girls in black?
There were. One left the stage, yes, but there's still something else. I'll back it up one more time. Grouping changed. The curtain changes color. Yes.
Yeah.
So if I go back in here and you rewind, well, look at the curtain, right? It's red and slowly and subtly transitions over to orange. And I'm not sure if anybody heard me say that my grandfather died when he was a baby while you were trying to count the number, right? So the point is that you can control the mind and the eye and the attention by users. Now we are at time, so the one thing we did want to highlight real quick is that there are a number of resources available to all of you in the community, whether it be community calls, samples, whatever the case may be, aka.ms/community/home. It is ending right now, Jonathan. Yes, we are wrapping up. There is a ton of community tools available to each and every one of you. We'll put this into the chat so that you can take advantage of it. We highly encourage you to get involved in the community. Hugo and I are both there to support, so please do support that. And we are here to support you. With that, Jonathan, hopefully we gave you enough time to close up. Back to you.